And we are live.
Awesome. Hello, everybody. Welcome to Meet the Maker. Um, Today we've got Kevin O'Connor here, who is the developer for Klipper firmware. If you've got a modern, I would say, flagship printer, a Voron, Rat Rig, I mean, any of the sort of cool printers these days, I feel like you're likely familiar with Klipper. You're a user of the firmware. So this is the guy that you can thank for that. Kevin, thank you for joining us today. I know you probably have a life and other things that you typically do on Sunday evenings. But again, thank you for your time.
Thank you. I appreciate the introduction here. I appreciate the chance to talk here. So yeah, definitely. Of course, the weekends can get busy, but I certainly appreciate these opportunities to reach out. So I'm looking forward to the conversation.
Cool. And if any of you guys haven't seen a Meet the Maker, this is just a conversation that we're going to have with makers in the community that do the cool things and support the cool projects that we love to use. And I think we've actually had a couple requests, Kevin, for you in the past. So I'm excited to have this conversation. We are aiming for this to be about an hour-long stream. We are going to be flexible, so if it's either shorter or longer, we have more questions, we'll sort of keep it rolling. But Kevin has graciously given his time, so thank you. Before we start getting into Klipper and all of those things, can you just tell us a little bit about yourself?
Oh wow! So I've been my background's actually largely in software development, and so most of my time has been deep inside computers, working with algorithms and processing data. It was around 10 years ago or so, actually a little bit more, about 12 years ago when I first bought a 3D printer, and that had got me interested in it. To me, the big thing with 3D printers is that idea of taking data and software and algorithms, which I was very familiar with, and actually turning it into real world objects. And prior to that, I really didn't even make those kind of connections between manipulation of software and data and manipulation of real world objects. And that's where I started getting back and started getting involved into 3D printing back then. Things that I do outside of that, I mean, I'm still very much involved in like software and software development as a whole. But I also do like to go outdoors a lot. I like to go hiking. I would like to go running. I generally run, a couple times a week, and other things that are, outdoors. Which I guess part of that is kind of surprising. Like a lot of my life seems to be around computers, and then at the other side, I like to get outside and not be around computers or offices at all. So a little bit mix of both.
So your work is indoor activity and your hobby and fun stuff is outdoor activity.
Yes. Well, I think to a large extent, I treat 3D printing as also a hobby. I don't look at it as a career choice for me. My career had been in software, and 3D printing is also like a hobby, a passion, that kind of thing. But yes, as to your point, I try to do both the indoor stuff and the outdoor stuff. And when I make that, when I walk outside, I try and get outside as much as I can. Whether that's hiking or running or whatever.
Cool. Are you doing Clipper full time or do you have other job?
I do software development as a freelancer. So
Okay.
I wouldn't say that I do 3D Clipper full time, although the amount of time that I ultimately put into it is probably close to a full time job. But yeah, it's not something that I look at as my profession, so to speak.
Cool. I'm gonna just so we don't lose questions in chat, I'm gonna try to ask them as they come up, and then we'll sort of just dive back into our conversation. But somebody asked, I know it's Rob. So Rob is the designer of the Baby Belt and Baby Belt Pro 3D printer, little belt driven printer. Rob, we've Alan just finished building a beta unit for that, so thank you. That's a cool little printer. Um, but his question is, do you have plans to re-implement shared heaters and mini and one out mixing hot ends? Let's go with the shared heaters piece.
That's a good question. I'm not actually sure that I've looked at that closely. Um, I don't have any immediate plans for that. I don't see any particular issue with implementing something along those lines. One of the one of the things that does that is are we doing that for if I take a step back, if we're doing it for like the main Klipper software base, are we doing it for a whole line of printers, or are we doing it for like one person? So there's
Okay.
always a trade-off there of if we're going to make a change, we want to make sure it's something that supports a large number of users. And so yeah, if there's a market for that, I don't see any particular issue with doing that.
So actually, yeah, then actually gonna start queuing some questions because I'm curious. So you probably, and I'm sure this session's gonna have a bunch of them, get a lot of asks or requests, suggestions for things to implement and changes and things like that. How do you decide what to tackle?
So that's a great question, and it's always tough, right? How do you figure out what areas to change, what areas to spend time on? One of the big things, right, is just time limitations on my side in general. There's I have a certain number of hours a day that I can put towards Klipper, and I want to make sure that the stuff that I'm working on has, to what your point there is, have a large amount of appeal. Largely, I try and rely on other people that have been using Klipper for many years to kind of relay back to me what do they think is the most important things to work on, to kind of get that feedback from the community. So a lot of people, I try and stay abreast of things that are going on some of the Klipper forums, and gather feedback that way, but also from people that come out, reach out to me that I have a long-term relationship with, that can explain to me what they're seeing and what they'd like to see introduced. So there's no hard and fast mechanism that says this goes in or this doesn't go in. It's really more of a trying to figure out what makes sense from a time perspective and what makes sense from a long-term maintenance perspective. So if I'm making a change to the software, I want to make sure that that software is something that can be maintained over many years, and that also that it provides a usable benefit to a large number of users.
Cool. Rob followed up with that and said if you have any interest in pulling the Crooked Crow Clipper add-on, if you're familiar.
Crooked Crow.
So I'm gonna guess that
That's
you're not that familiar with it.
I am not that familiar with it.
Okay.
Yes, and that's one of those. Some of the thing there is I'm largely involved on the software side, and when it comes to some of the more interesting, intriguing hardware, I'm definitely interested in seeing it. But I'm not a hardware person per se, which means I'm not on the cutting edge of some of the hardware things that are being done. So if there's like a brand new piece of hardware, I'm the one in the audience going, "Wow, that looks cool," just like everyone else. I'm not the one there with the screwdrivers or the Allen wrenches and going at it with assembling it.
Fair enough. Speaking about hardware, what 3D printers do you have? You said it's a hobby, so you definitely have some. You write
Yes,
firmware for quite a lot now that are being used. What do you have?
yes. So I have actually relatively. So my apartment's not that big. It's under 600 square feet, and I have, as of last week, I had 5 3D printers in my apartment, and I was able to give away one of those. Of those 5, there's actually just 2 that I'm using right now. One's a Voron Zero that was actually given to me
Oh,
by the
cool.
Voron group. Steve, in particular, did quite a bit
Oh,
of
that's
work
amazing.
assembling that and putting the parts together. And the other one that I have is a Voron 2, and the Voron 2.4. And that's one that I assembled. And so if I print something and something shakes out of it, I know it's because I didn't do a particularly stellar job in putting that one together. I've had to reassemble the hot end a couple of times now, or the crimping on the wires and some of the things like that. Those are the 2 main printers that I use. I also
Okay.
assembled a Delta printer many years back, and that one is I no longer really use it. I keep it on hand if I have to test something with Delta kinematics, but ultimately it was a kit printer before Delta,
It was
before
really a
the Delta
thing.
printers became big as far as like you could just buy one. I actually got a kit and put it together, and it wasn't particularly the best of kits. So it's here, but I don't really particularly use it too much.
Interesting. So obviously the V0 and the 2.4, those are more recent additions post Clipper. So what were you using when you were developing Clipper?
So the printer that I had for the longest time was I bought a printer. I think it was 2012. It was a Maker Gear printer, not Maker Bot, Maker Gear, and it was a metal steel based 3D printer. For its time, I thought it was quite good, and that's where I was using that. probably the first 6 or 7 years that I was working on Klipper. Well, I guess the Delta printer came into that as well, but my main printer was that Maker Gear printer. And then from there, I actually printed out the ABS parts for the Voron 2.4 that I made, and then used that to build the Voron 2. And then after that point, I was primarily using the Voron 2 for my prints. I did feel that the step up in quality from that Maker Gear, which was a bed slinger type of printer, to the cube style was really cube style, and being able to enclose it and print ABS made a huge improvement in prints. Ultimately, I gave away that Maker Gear printer to my brother. Sometimes when I talk about 3D printers, I feel it's like almost like a gateway drug. I managed to give away the Maker Gear to my brother, and then he started printing out all sorts of stuff. And then he printed out his parts for he printed out the parts for a Trident.
Oh, cool. Awesome.
Voron Trident. And actually, now he's using that Voron Trident. To the best of my knowledge, that Maker Gear printer still works, but I don't believe it's really being actively used now.
But that Maker Gear printer sounds like there's a little bit of 3D printing history tied to it then. So that is the printer that you were using to test sort of the initial releases of Klipper?
That is correct, yeah. And that goes, I think it had a Rambo. Yeah, it was a Rambo control board, which is an old AVR 8-bit chip, which is one of the reasons why when I started the project, I went ahead and used the original 8-bit. I supported those original 8-bit chips. And then later on, I actually went through the process of upgrading it to a 32-bit when I actually put a Duet 2 Maestro board into it, and actually ported Klipper to that series of microcontrollers. Do you guys still hear me?
Yeah.
Yeah.
Oh, okay, sorry. I wasn't sure if the computer froze there. So I put it at the Maestro board, and that's how I handed it off. So actually, if you look back into some of the decisions on the early versions of Klipper, you can see that the choice to move to support some of the older microcontrollers was actually related to some of the hardware choices that you go back to 2012. You can see see the different types of boards. Actually, if you look at the field today, I don't see as many of those AVR controllers, microcontrollers that you do. They were actually very common back in, say, 2016, 17, 18. Nowadays, they're not so popular, which is a good thing. The newer microcontrollers are much more capable, much easier to program for, and much easier to support. But the architecture that I wanted to go with Klipper was the idea of being able to move a lot of the code over to a general purpose computer so that we could use many different types of microcontrollers and not be tied to a particular platform. And yeah, you can see that actually from some of the hardware that I was originally developing for.
Cool. So as we're talking about sort of I guess the history and what you were using to get things going and some of the hardware, what was the actual inspiration behind creating Klipper?
That's a great question. So if we go back, then when I first got that 3D printer, that Maker Gear printer, I was actually having a tough time with it. I think it was some of the things, if you talk to anyone when they first get into 3D printing, it'd be similar type of things. But I'd print something and it would fail, in the first few layers, or I'd get 7 or 8 layers in and it would fail. And I want to say that at the time I was printing, if I attempted to print, say 20 times, I might get success like 5 times. And that was actually kind of a frustrating, it was kind of a frustrating time for me.
Yeah.
When at some point I got it, and I think I printed a handful of things the first month or two after I assembled it. And then I probably let it sit for 6-8 months. And I came up and there was something that I definitely wanted to print. And I, again, went through the same process of trying to print an object, and, the first few times failed. And I kind of got frustrated, but that time around, I took a different approach, which was, I want to figure out why. Like, I know it's possible to print on this thing. I know that sometimes I get great prints and sometimes I don't. Why is it? And I started to dig into it as I had time available at that point. And as I kind of dug more and more and I started to understand more, I started to, I don't know how to really explain it. All of a sudden, all my prints started to improve in quality. And as I kind of identified things that I wasn't doing right, I identified things that I could improve upon. And all of a sudden, my print quality went up, skyrocketed. I was getting to a point where I was just about every single print I was attempting was successful. And in that process, I started to realize, like, a lot of the reasons why I was having failures was because the software wasn't doing what I was expecting it to do. And as I looked at it, I was trying to think about my background being in software. How could I change the software? What were some of the things that I could do to make the software work more reliably for what I was expecting? And as I got time available, I started working on it. Originally, it was just kind of like notes that I was jotting down, and then it was kind of like prototypes for code. And eventually, I got to the point where I decided, let me see if I can write out an initial implementation, and then from there, it kind of snowballed to that first release.
Cool.
So I guess the key here is A, as I wanted to address a problem that I was having, and B, there were certain things that I thought like I could really improve upon. One of the things that I was seeing was um, as I was looking at prints, I was noticing there were certain defects in the print that I could definitely tell was due to the way pressure was working in the extruder. And so my initial goals was, could I rework how the extruder does pressure? And today in Klipper, that's referred to a pressure advance or a smooth pressure advance. But that was also a driving goal, was not only do I want the software to work in a way that I felt was more reliable, but could I write the software in a way that I could model the physics a little better than some of the existing software? So at the time, the software that I was using was Marlin, and I don't want to say anything bad about Marlin. It does a great job, but looking at that software from a perspective of how do I model extrusions, the software just wasn't organized in a way to make that simple in my view. The software was largely organized around how do we get steps out, how do we move the motors as quickly as we can. Whereas I wanted to look at the software as more of a how do I make the physics work the right way, and then from there, if I figure out the right way to do the physics of the printing, how can I make the steps follow from that? And it was a different kind of way of looking at the software. That's the two that are combined of like, how can I write the software that I felt was a little bit more in keeping with how I look at the printing, and how can I do it with the way of physics first, so to speak, is what led me to that initial
Cool.
version.
Do you feel like you were successful out of your 20 prints? How many do you feel now are failing or are not doing what you're hoping that they're going to do?
So the 3D printing has come a long way since the 2012, 2013 when I first got involved. Generally speaking, if I print something, I will hit print, and I'll come back in an hour or so, and I will be able to pull it off the printer. There's a big asterisk there in the sense that since I assembled the V4 and 2.4, sometimes I hit print for about a month, and I realize I have to go in there and I have to recrimp the cables because I messed something up. But putting aside some of the errors that I had as far as assembling goes of the printer, I think the printer is in a state where I'm much better at getting successful prints. I don't have the same issues with print adhesion and things along those lines. A lot of that is again, I do think it's part of the software, but I think also the hardware is just a lot nicer. The enclosed chamber, having temperature sensors that are better, having a much better hot end, a much better extruder. They all contribute to higher quality. As far as the software, looking back, I think there's a lot of things that Klipper has done successfully over the last the last 8 years. Some of the things that I think that Klipper has done that has been really successful, at least when I look back from my perspective, is I think Klipper has, I don't know how to really word it, it kind of moved the bar, so to speak. If we look at software from 8 years ago to today, there's certain things that I think are kind of given today that if you look back then would have been considered like impossible to do. So some of the things that Klipper has done, for example, is the idea of moving a lot of the software over to a general purpose computer instead of doing it all on a microcontroller. There was talk of that in 2016 and 2017, but really I think Klipper was the first one that said, that could go into that space and say it's not just talk. That is a way that we can do it, can be successful. Some of the other things I think that have been kind of game changers, so to speak, is back in like 2016, 2017, all of the commands to the 3D printer, the so-called G code, were these to me very cryptic commands like M236.4 F14 S27 or something like that. And that was supposed to mean something critical to the printer. And with Klipper, if you look at the actual command reference for Klipper, yeah, we support some of those commands, those traditional type G code commands like G1 and G4 and things along those lines. But like the actual number of commands that Klipper supports, I would say overwhelming majority are human readable commands. And if you go back 8 years ago, that was unheard of. Like no one was going to do that. It was actually it was almost like verboten that you would actually have a command that you could read the name of the command. And I think looking back, it's been a I think it's understood now that actually makes sense. There's nothing wrong with saying set velocity limit instead of saying M204.
Yeah.
But back then, it was not something that was a given, so to speak. And the other thing, actually, I think that, and I know that this will raise some certain eyebrows, but years ago, if the software detected a problem, um, it had to keep on going no matter what. Telling you that there was a problem or raising an error of some kind was again verboten. And I think looking at it now, I think there's much more of an understanding that look, sometimes the software does encounter a problem, and sometimes it's worthwhile to tell the user that there's a problem. And the reason why I think that's important is um, if I know that there's a problem, that the software tells me that there's a problem, it gives me that opportunity to go in and make the change to fix the problem, and then I can get higher quality prints, all future prints. And if the software never tells me that there's a problem, then I don't know that, and I'll continue to get spaghetti for months and months potentially until I track down the problem. And Klipper, I know a lot of people will raise an eyebrows, like I said before, about they don't like the fact that Klipper can report errors. But at the same time, I think there is an understanding that we're getting higher prints because being told when there's a problem helps you get higher quality prints. And if you go back just a few years, the idea of the printer raising an error and saying there's a problem was considered again verboten. And I think in that regard, Klipper has moved the bar, so to speak.
Yeah, that's interesting. Um, so I mean, obviously there's I think that's great actually. And I've done enough of Googling myself to try to then, figure out what steps I can take to, to fix given errors and things like that. Um, is there anything that you feel like Clipper hasn't addressed or I guess lived up to your expectation of things that you wish it would have done? Uh,
Yeah, it's also a great question. One of the things when I look at 3D printing today, an area that I don't think we're not at at a place where I'd like to see. I don't know that's necessarily a failure of Klipper, but ultimately we're not at the place. And when I print something, I think I and a lot of other people would like to be able to obtain a model, either download it online or get the model from a CAD program and hit print, right? And then get, whether it takes an hour, 2 hours, or 4 hours, doesn't really matter, but then go to the printer and pull out a high quality version of that print. And the software to do that, I personally don't feel we're there yet, at least on the open source side. And in the sense that there's quite a few steps that one has to go through from the point of having the model to actually getting a high quality print. That involves installing slicer software. It often, when you get the print, there's locations online that you can get a print or CAD programs, but often you have to reorient the print within the slicer program. You have to set up a profile. There are print speeds, there are print accelerations. Um, there are different slicer softwares that you can install and different settings. Then you have to take it, you get a G code file from that. You have to move it over to the printer, which has it's another set of firmware, whether that's Klipper or Marlin or something else along those lines. And that software also has to be configured. And if you take a new user that's not involved in 3D printing and you try and explain to them all the different steps that you have to take to go from, I obtain a model to I have a quality print, is still, I think, very long and arduous.
yeah.
And there's a lot going on there. And if I look back to where the community was 8 years ago, I think there's been some improvements in that regard, but I don't know that it's necessarily moved the needle as much as I would have liked to have seen. And I don't necessarily know that's a failure of Klipper or a failure of anything. As much as it is that there are things that I'd still like to see on the software. I think there's great steps that could be made on the software. If we just take it as comparison, if I buy a 2D printer, an ink-based printer, I can go to any particular website and I can generally hit print. And within a few seconds or a minute or so, I'll have a piece of paper that will generally look like what's on my web screen, and I don't have to go through the gory details of configuring, downloading, installing several different software packages. I don't worry about PDFs versus SDLs versus G code or anything along those lines. And I don't think we're there yet on on the software.
Interesting. Um, yeah, and I wonder if it's more, and I think I mean, you kind of said this, just sort of where we are at today. I mean, with things like AI becoming really usable. I mean, I just typed in, I asked for my homeowners association to do an RFQ, and I mean, literally, I typed like a few prompts, and I got something that looked like a request for quote for a management company. Like it's incredible. I could see taking a model and saying, you know, orient, with minimal supports, and I need this to be functional, or all of these things. Like, how far do you think we really are away from being able to just select a model and say, this is what I needed to do, and have something like AI slice the file and send it to your printer?
That's a great question, and I have to say I don't know,
Okay.
right? I don't have that expertise on this on that side. I haven't looked at it, but I do
Okay.
feel like that's the next big area. From my perspective, that is
Yeah.
the next big area. Um,
What
how do we make the software easier to use as a whole, not just in one small
totally.
area, but how do we do it as a whole?
What slicer do you use, or is there a slicer that you feel like is sort of best, works well with Klipper?
That's a great question. I'm not an expert on those areas and stuff. I tend to just use Bruce Slicer just for no other
Mhm.
reason than I've been using it for a few years, and uh, I don't. I guess it's
Have
just not an area that I was like doing exploration on. I've heard great things about Super Slicer and Orca Slicer, but just haven't personally used them much.
Cool. Somebody asked with SBCs becoming sort of more powerful, are there plans to allow Klipper to do more asynchronous operations while you're printing?
Um, yeah, that's a great question, and that's one of the goals I had when I originally wrote Klipper was, as single board computers, SBCs are getting more powerful. Can we ride that wave? And that's one of the reasons why when I built Klipper, I wanted to make sure it wasn't tied to the Raspberry Pi in any particular way. As a whole, for the most part, Klipper is just a regular application running in Python that communicates with microcontrollers. The At this point, we're not really hitting any limits on the microcontroller as far as the number of threads or the number of cores. So we can certainly make it more multi-threaded, more ability to scale with more processors. But I actually am not seeing that as a requirement right now. So I would say we probably don't want to take on any additional maintenance load for to use more cores until we get to a point where we need to use those additional cores. The Raspberry Pi 3 and the Raspberry Pi 4 and similar processors of that line, they actually have quite a bit of capacity even in a single core. I typically see on my printer hitting about 20% of one core typically. So Klipper, the host software is actually multi-threaded, so you can use multiple cores, but even in the worst case, I'm seeing about 20%.
Well, the
Okay.
um, the question about asynchronous there was really about asynchronous operations. We've got some people that are working on an automated filament changer. So the idea of being able to have the printer printing while you could be having an AFC, spooling or unspooling filament rather than print, stop, do something with filament, resume kind of workloads versus,
Okay,
a multi-core operation.
got it. Yeah, so actually, the backend of Clipper should be largely asynchronous. The only thing that would not be asynchronous would be the command queue. So you can only run one command at a time. But if you pull back that veneer, so to speak, on Clipper, it does allow for multiple asynchronous operations. And indeed, we are doing quite a bit of stuff that's asynchronous. That's a requirement, for example, for if we're moving the X motor, we have to make sure that we're doing that independently of the Y motor and the Z motor. Um, and you can do it, for example, with I'm trying to think of another example, like the extruder is moving, parallel, and the stepper motors are moving parallel, and that the whole command stream between the front ends is all done asynchronously. So that the capability is there. It's just a matter of how do we encode the commands back and forth to allow it to to command it in such a way that we so that it's realistic to synchronize the events in a way that makes sense. So you don't want to be in a situation where you're, for example, telling I don't know, the filament spooler to move forward while at the same time you're trying to extrude backwards, kind of thing. Like you have to be able to organize the commands in such a way that they make sense for the total action. Yeah. So Klipper itself is definitely asynchronous. It's a matter of how you organize the commands. Did that answer the question?
I think so. Alan, address.
Um,
I think
yeah,
yes. I think it does. Yeah, thank you. So I didn't know this was I guess a limit, but somebody asked, is there a reason why there's not more than 400 megahertz in Klipper for the MCU? Is there like a restriction on, I guess, on how much they can?
Yeah, that's there. It just has to. There is a limit to 400 megahertz for the timing loop. It's actually like just a low level gory detail of, we want to make sure that when we send a command to the microcontroller, that we can actually put the timestamp for the command in a 32-bit value. And a 32-bit value can store a number up to 4 billion. And if you have more than 400 megahertz, that would be more than 10 seconds, which is plus or minus 5 seconds. And if you so if you had, for example, 800, you could only encode a value that was more than plus or minus 2.5 seconds. And then it doesn't give us enough time in the software or enough time in the scheduling to get the command from the host into the microcontroller reliably. So just as a how do I word that, just as a way of encoding the messages, we always try and make sure that we can send a command with a valid window of 10 seconds. It's not actually a limit of the microcontroller. So you could run the microcontroller at a gigahertz. You just can't put the scheduling loop at more than 400 megahertz. The scheduling timestamps at more than 400 million ticks per second. So for example, you can use a Linux. You can use Linux itself as a microcontroller. That's done sometimes on the Raspberry Pi. For example, a lot of people will set up an ADXL345 accelerometer on Linux, and the Linux kernel runs it. It can run at 2 gigahertz, 3 gigahertz, and in that situation, we just have an artificial 50 megahertz timer system. It's a way of looking at timestamps by no more than 50 million ticks a second. So it is possible. It's just that we don't. We just typically just limit it to 400 megahertz. This has come up before once or twice with a handful of microcontrollers that run more than 400 megahertz. I think the STM32H7 can go over more than 400 megahertz. And the reason why we just decided to go that processor just slightly slower was because it was just easier to maintain. Going more than 400 megahertz didn't actually produce any real world effects. And just to keep the code simpler, it was easier to say, run it slightly slower than your max than it was to try and say, let's rework how the code works on that particular platform.
Okay, cool. Do you maintain a list that's publicly available of things that you're working on, or like an upcoming feature or priorities kind of list?
I try periodically to update people on Klipper discourse on things that I'm working on. I also keep a development repo available where I'll put like snapshots of work that I'm doing, and then I'll announce, typically on Klipper discourse, that I'm working on those particular areas. It's not something that's how do I word it? It's not something that's like officially like an official process, but generally, if I'm working on anything for more than like 2 or 3 weeks, I will let people know in one place or another.
Okay.
I'm sorry, but would you be willing to talk about the things that you talked about at Vice? I think
Sure.
people would be a little interested to hear about the things you're working on.
Yeah, so I guess one of the big things that I mentioned when I was out in Reno back in October was the idea of adding an official Klipper extension system. So one of the things I've seen over the years is that there's a lot of people that are interested in working on the Klipper system, and we've had a large number of these, I guess, modifications to the Klipper code. This is where people will add a file to the Klipper extras directory, and it alters how Klipper works. one of the big challenges that happens one of the big challenges with maintaining the code when that occurs is that if we make a change to nearly anywhere into the Klipper software, that could be in the microcontroller, it could be in the Klipper host software, there's really no way to predict how that will impact a modification to the Klipper code that someone else has made externally. So for example, if someone adds a file to the extras directory, let's say it's the G-code shell command or something along those lines, they're going to be interacting with the rest of the Klipper host software and potentially the Klipper microcontroller software in such a way, but we won't necessarily know, me being myself and other core developers working on the mainline Klipper code, we won't necessarily know that, and we'll be making changes, and we could easily break those code bases as we make a change. And that leads to a lot of heartache, both among developers and among users. So one of the goals that I had talked about was if we can make a system, a Klipper extension system, an official Klipper extension system, so that we can document the official API codes that were, API is an application programmer interface. It's a term for software of, basically officially documented ways of interacting with different software. If we can do that and publish that, it'd make it, I think, hopefully easier for people to enhance Klipper in such a way that they can do it so that if we make changes going forward, there won't be this back and forth of, did it break something? The other thing that comes up is if a bug is found, where do users report it, right? Where it is now, currently, there's definitely a challenge with, bug is found, but does it have something to do with a modification that was made locally that, for example, changes to the local code or addition of files into the Klipper repository extras, or something to do with the core code? And what often happens in these situations is you get like, I would call it like finger pointing, where one developer says, no, it's not my code, it's your code. Another developer says, no, it's not my code, it's your code. And that just doesn't lead to a lot of productivity. It's not a happy feeling for users. So having an official extension system, I think, would help with that. That was one of the core things that I spoke about in Reno. Another thing that I spoke about when we were in Reno was this idea that I had of extending the stepper motor phases idea. So there's actually a module in Klipper today called Endstop Phases, and it allows you to use the so it allows you to use the precision of the stepper motor and how it transitions from one position to another by going through a series of phases. So if a stepper motor if you configure it for, say, 16 micro steps, for example, the motor will move a series of 64 phases. It's 4 full steps. And so that any particular position anytime the motor moves along, anytime the rail moves along, anytime the carriage moves along a rail, if it's in the same position, it should be, at any given time it's moved in the same position, the stepper motor should have the same phase. And we can use that knowledge to make end stops a little bit more accurate. The way that works is that if you move the carriage into an end stop, ideally it should be at the same stepper phase every time you do that, because ideally every time the carriage moves along the rail, it should hit the end stop at the same location and thus the same stepper motor phase. And that you can actually improve the accuracy of the stepper motor. You can improve the accuracy of the end stop by using that system, because the end stops typically can vary by, 5 to 10 microns each time you hit it. And that's just because the hardware itself will have some variance in it. So taking that information from the stepper motor, knowing what phase it is, the stepper motor itself with its phases are often better than that kind of distance. You can often get the stepper motors configured in a situation where you have maybe 1 or 2 microns, or even a fraction of a micron for each phase. And so if you go to an end stop, and it says, for example, you're not on the same phase, you can recognize that, well, the reason why it's not on the same phase is because the end stop must be slightly less accurate, and use that information to say, okay, I must have slightly overshot or undershot the end stop this particular attempt. So that capability has been in Klipper actually for quite some time, but unfortunately, it only really works for motors that have a traditional type of end stop on the Z rail. Typically, you want that accuracy on the Z motor. a lot of printers now don't have an end stop on the Z. They either use probes, or they will use they use Z probes, or they will use things like quad gantry level or Z tilt adjust. These are where you have multiple Z motors, and the Endstop Phases system really doesn't work on those type of printers. But I believe it actually is possible to extend that system to the newer printers by a little bit more logic, and that was an area I was looking to work on.
Sweet, that's cool.
Yeah, so those are a couple of things that I talked about in Reno for a bit.
Yeah, how was Reno?
It was a lot of fun. So I don't actually get a chance to go to a lot of these get-togethers with 3D printing in general, and so being able to see a lot of the people that are working on these type of areas, and in particular on the both hardware and the software. Again, my background's mostly in the software. So when I see people that are putting together these great printers with the hardware, I'm always impressed. I just some of the newer technology and getting to see that the challenge that they're having is great. So it's great to reach out, great to see some of the stuff that's going on.
Sweet. Yeah, no, it sounds like it was a really awesome event, and I'm kind of bummed for not going, and Alan made me really jealous of how cool it was. So I'm hoping they do something again next year or shortly, soon, so I can make the excuse to go do something and hopefully see you in person. It'd be awesome. Have you made it to any of the RepRap events or anything? So it sounds like you've been in 3D printing since like 2012.
Yeah, so years ago, I've been to a bunch of those Maker Faire events, and they were always fun. I don't think it's been as popular the last few years. And then I've been to ERRF a couple of times. Yeah. That's the East Coast RepRap Foundation, which I think they renamed it this last year. Although
3D Printopia.
Yes, exactly. And then Voron Device is the other one I've been to. But no, I unfortunately have not been to Murph or the Rocky Mountain one, or I know there's a bunch in London that sound like a lot of fun. But
Smurf, I think is it's the one in London, or the one in the UK. I think it's in Oxford, but that's
this year's Manchester.
Is it man? Okay, so they're moving it. Cool.
Mm-hmm.
Cool. I wonder. Yeah, never mind. Let's see. And we've got some questions, and so one thing I've actually got more questions than I'm sure we have time for. One thing I do ask is, if people are asking us questions that we don't get to, is it cool if we just reach out to you and just ask you, just on Discord or however Alan's making contact with you? Are you willing to answer some after the fact?
Yeah, sure, of course.
Awesome. Cool. So guys, if we don't get, I am trying to record all these. So if I don't get to everyone's questions, we'll try to compile those and send them out. And then we'll post on a blog or something. That's the part we haven't figured out, is how to necessarily get back to people. Cool. Let's see. So a lot of people have been asking about load cell, and is there any development that you're working to I guess make load cell improvements or improvements?
Yeah, it's a great question. I'm definitely curious to see how that's coming along as well. Gareth, I met Gareth for the first time out in Reno. Garrett's a person that's a developer that's been working on load cells for, I want to say, over the last year, and he's been active going over some of his experiments on the Klipper discourse. He was also out in Reno and was demonstrating the hardware that he had available. It definitely sounds very interesting. He's got it set up locally where he's actually homing the printer, going through different test cases, and he actually has it set up quite interestingly as a means of gathering data. So he's able to, for example, show what the load cell is doing even during the middle of a print, which is actually kind of interesting. You can see how it responds to pressure, just normally extruding filament, and as it's moving around, as the tool head, for example, does cornering and other activities, you can see that the load cell is providing all of this information. He's actually been the one that's been working on it firsthand. I don't actually have a load cell here locally, and he's been submitting some code. The initial support for the sensors went in a few months back, There's a support for, I want to say it's the HX717. And then there's I want to say it's an ADS, I don't know, ADS 12, something, I'm not sure. So that's sensors supports have been added into Klipper. The next step is going to be supporting of the actual load cell, just getting the load cells into a way that it can not just have the sensors reporting the raw numbers, but actually support the amount of weight that it's detecting. And then the step after that is actually to add in the support for homing and probing for that load cell code. So it is a work in progress. I definitely look forward to seeing it, and yeah, I think we'll definitely be going there as a whole.
Cool. That's awesome. I opened up with saying basically if you've got a modern printer or any flagship printer from any, of the main brands out there, I mean, probably outside of Prusa, you've experienced using Klipper. I am curious, do you have any usage statistics or anything like that on there? Because obviously in the last few years, at least, it seems like it is becoming a much wider used firmware.
Yeah, that's a good question. No, that's actually a challenge from the open source software perspective. Is we don't really gather usage statistics. I do have just general statistics for how many people access the GitHub repository or how many people access the website, and we can definitely see a trend over the years of an increase. We can also see general trends like right before actually, I guess right after the holidays, from late December into early January. You definitely see a lot of people that are interested. Yeah, a lot of people interested in the software. And that's probably people getting printers during Christmas and things along those lines. I definitely know the community is large. Can I put a number on it? No, unfortunately, I could not put a strong number on it. There have been discussions in the past of could we gather usage statistics, and it's a challenge, right, from an open source software perspective, because nobody really wants to gather anything that could be considered private. And
I'm guessing it's a you could, but is it really a thing that your users are going to appreciate? And is it, to some level, is it the right thing to do?
Yes, right. And also, do we want to put anyone in a position where there's potentially gathering sensitive information and potentially how do I word that? Downsides to that, even from that person gathering the information.
Certainly. I mean, I could see where, I mean, there may be jurisdictions that are not friendly to people using 3D printers and things like that. I mean, I could see there being, reasons that it wouldn't be desirable. Other than, I think, and I mean, that there's a lot. I'm sure we started allowing, or we have like a retail allowing. Wow. We have a retail space that we opened up in May, where people come in and get things, and it's pretty common that people, even with with Enders or other Creality machines, that obviously were Marlin when they purchased it, to do upgrades. So I think that even though we're seeing all the new cool latest greatest printers all with Klippers or their own variant of Klipper being run, there's also a lot of those Marlin users that are enjoying some of the benefits. The one question I get, and I can never, I mean, I can't give them a definitive yes. I think there's a lot of features in Klipper that can improve your printer's performance, but people always ask, am I going to get better print quality by upgrading to Klipper or by installing Klipper? What should I tell people?
That's a great question. So a big determining factor of quality is the hardware, and then after that, a big determining quality is the configuration. And so, no, I don't think that there's anything that software alone would say, right away, just changing the software somehow is going to improve the quality of your prints. But that said, if you were going to take the time, if you were going to take the time to say, I'm going to look into how to install the software, go through it, then that certainly would be an opportunity to also take a look at some of the configuration issues, potentially looking at the configuration and finding issues and addressing those issues. And that could certainly improve the quality. So if I go back historically on people that, not so much now, because you see a lot of people now that are using Klipper that potentially A, came with the printer, and B, they're following guides for the first time with that printer. But years ago, when Klipper was always when Klipper was not being the default choice, and people had a to upgrade to it. I definitely saw a trend of people that were saying they installed Klipper and saw an improvement. And I don't necessarily know that's something that was implicitly in the software that made it go better, but it's that act of addressing something that opening up the box, so to speak, on the printer and saying, I want to make a change. And then when you walk through that change, there's an opportunity there to actually improve the results. Now, that said, there are also things in Klipper that I think it does quite well. So, for example, Input Shaper does quite well. Pressure Advance, in particular Smooth Pressure Advance, Klipper I think does quite well. I would call it a so-called industry leader in that area. And you can definitely get improved quality, but it is an additional step. It's not just like I've installed Klipper and all of a sudden now my prints are better. It's installed Klipper and I configured Input Shaper, and now all of a sudden you're getting better results.
Is there one feature that's sort of like your favorite part of a thing about Klipper, whether it's because it improves print quality or just, quality of life improvement? Is there something that you just say, hey, this was a home run?
I mean, there's a lot of things I think that Klipper has done well, and I think we were talking about this a little bit before. Of, I think Klipper did move the bar, so to speak, on certain areas. Some of the things that I think Klipper has done quite well is Input Shaper and Smooth Pressure Advance. I think Klipper did lead that space with Input Shaper. Pressure Advance, I think Marlin has Linear Advance, but I'm biased, of course, but I think that Klipper has done a better job with Smooth Pressure Advance. Those areas, I think Klipper has done quite well. I think Klipper has also done quite well at, I would say, being a little bit more modular, a little bit easier to work with, to extend. This is, in the macro system. This is its ability to add support for a large number of different pieces of hardware. Klipper runs on more microcontrollers than really anything else in the field. The ability to use the general purpose computer so that you can use a higher level programming language like Python to control it. I think Klipper has done quite well in that area as well.
So what language is Klipper developed in? Is it Python?
Yeah, so the two parts to it, the software is the part that runs on the microcontroller and the part that runs on the general purpose computer. Primarily the code on the general purpose computer is Python. There is a little bit of C code, but most of what developers are going to work on are going to be hitting the Python code. And then on the microcontrollers, it's C code that's being used. And that was done intentionally. The goal when I originally started the program was to allow, wanted to minimize how much logic was on the microcontroller, but with little code and logic that was on the microcontroller, I wanted to be fast and direct, and not as much layers as to what was going on. So if there was a problem in the microcontroller, I wanted as little code as necessary, just that it could be found and fixed as quickly as possible. And then on the host side, which is what I figured that most people would be looking at, I wanted to go something a little bit higher level, so that really the goal was that to allow more people to be involved. When I look at 3D printing, when I first went into 3D printing, I kind of alluded to this earlier, I felt like a lot of it was like this big black box. Like, it kind of does something and you hope it does the right thing. And it was often hard for me to figure out, well, what is it supposed to do and why is it supposed to do that? And as I started to peek through the different areas, I started to get a better understanding of it, and B, I thought, gee, this really it doesn't need to be low level. This could be done in a little more of a high level description of what's going on, because ultimately this is more about physics than it is about software. And I thought Python was an opportunity to describe that physics, to describe those high level actions in a way that was a little bit easier to present than some of the lower level languages. It didn't necessarily need to be the fastest thing in the world. It really just needed to be accurate.
Okay. So from when you started conceptualizing and writing Klipper, first, actually, before I ask that, do you remember the first line of code that you wrote for Klipper, where you started?
Wow. So it's not, when I write code, I don't actually start with code, right? The first thing I do is I write an outline about like what are the areas that I want to accomplish, and then trying to figure out okay, if these are the areas I want to accomplish, how do I break them down into modules, segments? The actual very first, I've never published this code, but the very first take that I had on Klipper was everything in the microcontroller. and I was working on how could I send up, how could I parse commands in a way that the microcontroller could keep up. This is years back. Ultimately, I didn't keep any of that code. I decided that that wasn't a system that that wasn't going to work out. And then I had stepped back, moved a lot of the code into the general purpose computer, the Python code. Geez, what did I work on first? I don't know. Again,
Okay.
when I think about
That's
working on
fair.
programs, I actually think about like the outline. I started with an outline of what were
Okay.
the major modules that I needed, and then went from there.
Okay, cool. Um, do you know how long it took you to, I guess, get to a point from where you did the outline to getting something that you thought sort of was generally usable for like a wide audience?
Way too long. It's a great question because I think I released the first version of the code in like mid 2016, and I was working on it. I want to say it was early 2015. It was a good year and a half before I released even the initial version of the code, the initial hello world kind of thing of the code. Um, the challenge I was having was that I wanted to do a lot of the code in Python on the host computer, the general purpose computer. But I was finding is that Python at the time could not keep up. There was two reasons for that. One was that the Raspberry Pi computers that I was using at the time were a bit slower. I actually had started with a Raspberry Pi 1. And the second reason for that was some of the low-level actions at the time, handling the communications back and forth with the microcontroller. I had written entirely in Python, and it was not able to keep up. I needed to respond within about 100 milliseconds, 200 milliseconds to events on the microcontroller. But there was times when Python was not just wasn't able to meet those timing requirements. I had done a whole bunch of things with at the time. There was a program that was popular called PyPy. It wasn't this idea that you could compile Python on the fly to make it faster. And unfortunately, during that whole process, I I was finding that it was also, it would run as a whole faster, but occasionally it would just glitch. Not glitch is not the right word. It would just take a slowdown a little bit. But then if it just happened to slow down at the wrong time, you would miss those 100 millisecond, 200 millisecond timing requirements with the microcontroller, and you just get all these errors. And I was fighting that for months at a time. I kind of shelved it for a while just to think about it. And then when I finally got back to it, I thought, well, if I just write some small segments in C code, that should not have those problems with keeping up. And that's the first. That actually is what led to a successful initial revision, which was having the some of the step generation code, some of the step compression code, and some of the serial handling code in C, and those have the most intensive time requirements, and thus they could be done in a way that was most processor efficient. While the rest of the code, this is things like the config reading, the handling of the high level handling of kinematics, the high level handling of how command processing done, that could all be done in Python because they were not CPU intensive.
Interesting. Is there two-part question? Do you have any regrets for choosing Python? And the other one is, are there any restrictions or annoyances that you have in sort of the more current versions of Python that you're working with?
Yeah, yes, and yes. So regret. I mean, I can't say it's regrets because if I take a step back now, I don't know what a good alternative was. So I do like the fact that Python is a high-level language, and I do like the fact that it allows for an easier approach to to large portions of the code. In particular, as I was saying before, a lot of 3D printing is really about the physics, not necessarily about the code implementation. And I think Python as a whole does a generally good is generally good at that. The regrets that I have is that the system as a whole is more error prone as a whole. It's more complex as a whole, and this I think is and it's not that it's not right or wrong. It's a trade off, and it was a trade off that I knew when I went into it years ago. Is we can move that logic from the microcontrollers into the general purpose computer and have much better control over it, but it does come with a cost of complexity. If there is some kind of communication glitch between the microcontroller and the general purpose computer, as an example, you're going to end up, or there's a good chance you'll end up with an error. And often those errors are very cryptic. This is where we see things like timer too close and stuff along those lines. That's not necessarily something against Python per se, as it is more the architecture between the the host and the microcontroller. So you get the benefit of it's easier to extend and a whole heck of a lot faster. But the downside is that if something goes wrong, it's often harder to figure out why it went wrong.
So on that cryptic message of the timer too close, we've been asked a couple times about what that means, and I'm guessing there is not a straightforward answer. But can you?
Well, so what it means, it does actually have a defined meaning. What it means is that the microcontroller has a scheduler which figures out exactly when to run each action, and it's very timing precise. If it is told to schedule an action at a time that is in the past, that is called a timer too close. So, for example, if you say turn on the heater at timestamp 101.3, and it's 104 at the time that you get that command, that is a timer too close. It cannot turn on the heater at 101.3 if the current time is 104. So that is the actual, what does it mean? The unfortunate part about that is, okay, but what caused it? Why did I get this? Why was a request sent to the microcontroller that said schedule this thing in the past? And unfortunately, there's no simple answer for that. There's a variety of reasons why it could occur, and that's why it's kind of cryptic. So the most common reason for it is some kind of communication glitch between the microcontroller and the host, or if the host can't keep up. So, for example, the host was trying to organize a whole series of events over the next, say, 2 seconds, but it got so slow that by the time it sent out the commands for the next 2 seconds, it was already in the past. That could cause that error. It can also happen, for example, if it's scheduled out, it was trying to put together the series of commands for the next 2 seconds, but the serial port, for whatever reason, was not responding properly, and it took it 500 milliseconds to recover. By the time it starts getting those commands, now they're in the past. And the third likely reason is it could be a bug in the software. The software tried to schedule something. It wanted to schedule something the next 2 seconds in advance, but whatever software glitch it tried to say, turn the heaters 10 seconds ago, and then it just resulted in error.
Interesting. Well, thanks for explaining that. Hopefully, at least some of the people at least have an idea of what was happening. And unfortunately, it looks like you need to do some digging, people, to try to figure it out, or hopefully it just happens once and it doesn't happen again.
Yeah, I mean, that's often in practice what we see when that happens is it is often a system error, and that this machine is either totally overloaded or it is a communications problem, and it's often, for example, we see errors like that, and when people actually track it down and let us know, they'll let us know, like, for example, the power supply was not grounded properly or things along those lines, causing a whole bunch of distributed errors. We also see that it doesn't typically happen on like production printers. It's often on like homegrown printers where people are actively doing a lot of different work, where potentially wires could be loose or things along those lines.
Interesting. Moving away from strictly Klipper sort of discussion, are there any other software program that you've worked on?
Yeah, I mean, so professionally, I've worked on a bunch of different software, in particular in the financial services area. On the open source side, the big thing that I'm associated with is a program called CBOWS. So if you use any of the Linux virtual machines, this might be an area that's kind of esoteric, but there's a software package called QEMU or KVM that allows you to emulate another operating system. So if you ever run Linux and you've started up a Windows guest, for example, under Linux, that typically uses QEMU or KVM. The CBOWS is actually a software package that I wrote that emulates an old style x86 BIOS. So if you ever turn it on an old computer, it'll boot up and it'll have something like press delete to enter the BIOS. I wrote a package that implements that for both virtual machines and real machines. And then actually that package is quite popular. It's shipped by default for most Linux distributions. I think all the Linux distributions, and there's probably, because of data centers like AWS and rack space and all that other stuff, there's probably several million instances, probably hundreds of millions of instances of CBIOS running around the globe. So that is also
Wow,
open source.
yeah, that's awesome. That's actually really cool. I don't know. Do computers not do that? Press delete to enter BIOS anymore? You said the old computers, and now you're making me feel really old.
They do. It is still you actually will see messages like that, and they don't typically call it a BIOS anymore. Now they call it UEFI. It's a similar concept, but slightly different name, I guess.
Yeah. Now that's awesome. I had no idea. That's really cool. I want to be cognizant of time. And we do typically do sort of a trivia, give away prizes and such. And I believe that you've come up with a couple trivia questions. Is that right?
I did. I don't know if these are going to
Yes.
be easy or harder.
Okay. And it's okay. If they're really hard, we'll start giving away hints and we'll eventually get to the right answer. Um, we, let's see. We did not pre-decide what we're giving here. Let's hmm. Let's go ahead and we recently started carrying Vision Miner. So let's give away some Vision Miner. So whoever gets a trivia question right will get a 50 milliliter pack of Vision Miner. And we'll do that for like two of them. And I have a trivia question and I'll try to think of something else for that. Kevin, do you want to go ahead and ask your first one?
Okay. So this, yeah, I'm just trying to think of which one to ask. How many questions do you want to ask? One, two, three?
Yeah, let's as many as up to three.
Okay. What is the version number of the last released version of Klipper?
And I've got live chat turned on, so there's like a couple second delay and they'll start coming through chat and I'll get it. We got .12. Are you able to see the chat?
I am not able to see the chat
Okay,
now.
I'll just start reading out. We got V0.12.0.
That is correct.
Okay.
Well, are we going to take Josh's answer
Yeah,
because
which is
he had
just .12.
Or do we need to be decimally correct?
I'll let you guys know what correct is, but it would be V0.12.0 would be the. I'll let you guys figure out what the correct one is.
I'm gonna give it to both. Thunder Keys wins every stream he's on. And he was the first one to get it right. So I want to give Josh his moment of glory. So both Josh and Thunder Keys just reach out to info at West3D and we'll make sure to set up an order for you to get that, or we'll send you a coupon for it. Let's see. I will go ahead and I'll do mine and then we can ask yours. This one will be for a free roll of ambrosia filament. Any type you guys want. There is a printer that just had a potentially fiery start. There was an issue with the SSR. Which printer is that? Yeah, I got okay. Alan got it right. It's the Key +4. People name the manufacturer. It is the +4. Alan, if you want to reach out, we'll send you a roll of ambrosia filament. Fun fact, we actually ordered that printer, and we are waiting until they get the right, like they have a new SSR that's supposed to not take in too much current. So we were waiting for that, and then we will actually offer the printer. But glad we heard about that issue before we actually paid for the order. So yay, Alan. You won a roll of ambrosia filament, so congrats. It is a cool printer, by the way, and I think they are sending out free SSRs. If you have one and have not reached out to Kitty, please do that because they will give you a new SSR that won't burn up. Go go ahead, Kevin, if you've got another question. This will be again for 50 milliliters of Vision Miner.
What is the name of the math algorithm used in Klipper's resonance tester? This algorithm is also commonly used for fast convolutions and is also often used for radio decoding.
Ooh. Let's see, bicubic FFT convolution.
I believe Dr. Wang was the First one to get it correct with FFT.
Yes, FFT is what I was thinking. Or fast Fourier to transform.
Yep. And then like 4 people after that, like actually elaborate on what FFT was. So perfect. So yeah, who was that, Alan?
Dr. Huang.
Awesome, Dr. Wang. If you could again reach out to info at West3D, we'll get you that was for Vision Miner, yeah. So we'll get you some Vision Miner. Do you have another one, Kevin? You said you had up to 3?
I do have a third. I can
Let's go for it.
This
Yeah.
one is, we might have to go with closest on this one. How many config options does the latest version of Klipper have, at least as documented in its config reference?
A lot.
A lot is true, but that's not the answer I was looking for. Alan, you know the answer to this, right?
I do.
Chats that I sent you? Okay.
And we'll go for closest. Let's just give it like 10 seconds.
It is not integer limit or all of them.
Oh. Yeah, I have no idea what I would say. Price is Right rules, sure. Closest without going over.
It is not a number. Robert, it is not n+1. Let me know when you want to call it.
We can go ahead.
Okay, closest without going, well, someone went over, but the least. You want to call it that?
Sure.
Tanner Fenningsdorf with 1260. The actual answer was 1216.
Oh, and that was by far the closest, so that's fair.
Yeah.
All right, Tanner. Yeah, just reach out. Okay, let's do one more fun one. Because I'm excited to get these in. And it would just be a fun, nice thing for the holidays here. This question, we will provide one of these things if you get one of the answers right. If you are in our if you're in our we can't talk about that. If you're in our Discord channel where maybe you would have seen what we're providing, you can't answer this. Some of you may know that we've worked with Out of Darts. We carry dart blasters that are 3D printed projects. We are bringing in 3 new dart blasters. If someone can name one of those 3, we will send you a free dart blaster.
All right, Daniel, this one's on you because I don't even know what they are.
Let's see. Yeah, I think my chat I think I need to just refresh 1 sec.
Okay, and
I think we've got it though already.
And for winners,
Slab. All right, Josh, I think you already won, but you won again. Slab is one of them. So we're gonna carry the Slab, the Cynthia, and the Quick are the new ones. We already do carry the Lynx. We carry the Lynx, Talonclaw, and Caliburn currently. So we'll now have 6. Josh, congrats. Hopefully it's a fun sort of Christmas gift. You can have a nice project. We should have those in the next week or so. And so we'll just send one out to you whenever we do, including that email. Because again, I think you won 2, that you won that, and we'll go ahead and make sure we send it out to you. Kevin, did we lose you?
We have lost Kevin. He is having trouble rejoining.
No worries. Well, we were going to call it because again, I wanted to be cognizant of time. We said it'd be between an hour and about an hour and a half. So we are there. We asked, I think, most of the questions. If there's anything that came up in chat, I have recorded them, so I'll make sure to ask. And if there's something you really wanted, you can reach out and we'll make sure to ask Kevin for it. Kevin's not here, but thank you for the time, Kevin. That was awesome. And thank you guys for joining. Hopefully you guys learned a lot, had some fun just hanging out And we will see you next time, which, Alan, we have a date for that, right?
We have a tentative date, yes. The person is in chat. So, Armored Turtle, we're still good for December 8th, right?
Tentatively, we are going to be doing this on December 8th. We will send out all the regular notices and all that stuff so you guys won't be surprised. If you guys are curious, because it's the most popular question we're getting right now, is if we're going to have any sort of Black Friday deals or anything like that. Yes, we are still figuring out what those are. So stay tuned. But there will be things, and we will post that on our mailing list, and it'll be on our website and all that. So again, thank you guys for the time. This was really great. My wife is going to be thrilled that it only took us an hour and 20 minutes. So have a good one, guys.
Take care, everybody. See you soon.
Bye.